So we have seen that as an example that we have a situation where there is a particular node whose balance factor is violated, and we have to correct this. But we have to understand how we can correct, what are the various situations can arise, and what are the possible solutions for that. Then only we can proceed for a general case. So let's take case 1, and suppose, assume that there is a data is something like came as 1, then 2, then 3. Okay. So your binary search tree will be created something like 1, then 2, then 3, right? So it is basically, now if you calculate the balance factor for this particular node, it will be something like the balance factor of this leaf node will be equal to 0. The balance factor of this node is equal to, left side height is 0, right side height is 1, so it is -1. And balance factor of this node is equal to, left side again 0, right is 2, that means -2. So we have a unbalanced situation with respect to the root, what we can see over here, right? Now see, we can basically consider this situation as, you see, then this case 1 actually, what we can say, let's write it here. Can say that right subtree right heavy. Okay, and your data set was 1, 2, 3, right? Now see, this is important. Right subtree right heavy. What does it mean? Mean, you see, when we will find a particular node which become unbalanced, we have to see what, under which case it is unbalanced. Okay, so the case 1 just we are considering, we have 4 different cases. Okay, so case 1 is for right subtree right heavy. What does it mean? You see, just look after this particular situation, that this node is unbalanced. Now just ask yourself that which part is unbalanced. The right part is unbalanced. That means the right subtree, due to the right subtree, it is unbalanced. Now go to the just right child, I mean root of the right subtree, and you see the right subtree, I mean which part is heavy. I'm not saying which part is unbalanced. I'm saying which part of the right subtree is heavy. The right part of the right subtree is heavy. Again, right? So that is why the case 1 we have considered that right subtree, right heavy. Now what is the solution? The solution is that, solution you can say that left rotation of the tree, especially you can say of the BST, with respect to the unbalanced node. That means this node. So you will have a left rotation will be something like this with respect to this unbalanced node. Now just assume a situation that they are in a queue and you are there is a pulley and you want to do a left rotation, what will happen? This one that is right now and at the top will go downward. What was in the right side of 1 will become the root of the tree, and right side of 2 will remain what it is right now. So that means due to this left rotation, what will happen? This one will change from, this one will come in this side, 2 will go upward, so 2 will become the root, and then 1 will come below these 2, and 3 will be as it is. And if you calculate the balance factor for these 3 cases, it will become something like, it's the balance factor is 0, leaf node, balance factor is 0, again leaf node, and height of the left subtree is 1, height of the right subtree is 1, so it is 0. Same, that means their difference is 0. And now you see this particular tree become balanced. So if you do a in-order traversal for both tree, you will find same order 1, 2, 3. But the difference is that this is unbalanced situation and this is a balanced situation. So actually what you have to do to answer this question, if a arbitrary set of numbers is given to create a BST, actually AVL tree, then when you will find that some tree is unbalanced, some node is unbalanced, the first job that you have to identify under which case it is unbalanced, and second point is that you have to rotate it properly. So you have to visualize or realize the way of this rotation. But this is a very small situation. We will see as an example later what are the adverse situation can arise. So we will see it very soon. Now go for case number 2. Case number 2 is a little bit different. That is right subtree, opposite one, left heavy. So the situation is something like that. You have a data something like, again say data is given something like 1, 3, 2. So your BST that you will create will be 1 will be obviously on the root because it's the first data, then 3, then 2. Okay, and you see, just calculate the balance factor for this particular tree. It is obviously 0 because it is leaf node. The balance factor for this node will be what? Height of the left subtree, that is 1, and height of the right subtree, that is 0. So 1 minus 0 is equal to plus 1. And height of balance factor for this node is height of left subtree is again 0, and height of the right subtree is 2 again, that means minus 2. Although the structure is little bit different, but height of this particular root remains same. Because in previous case we had right subtree was heavy, right side of the right subtree was heavy, and here now left subtree of the right side is heavy. Doesn't matter for this node whether right side heavy or left side heavy. So now question is that if this situation happen, then what we have to do? You see, Here the solution contains two steps. That's step 1. Step 1 is that right rotation you watch it carefully. Right rotation with respect to the right child of the unbalanced node. And step 2 is, so let's continue the step 1 first. So what will happen? We want to do this one, right? Because right child of the unbalanced node is this one, and right child this one. So with respect to this right child of the unbalanced, that means the pulley is present here, and if you rotate only this part, you see this part remain unaffected, so 1 will remain as it is, but under 1 instead of 3 it will become 2, and under 2 it will come to 3, right? And you see now if you calculate the balance factor, it is 0, and it is 0 minus 1, that is minus 1, and 0 minus 2, it is minus 2. But now question is that why I have done this step 1? Because we have converted the problem from case 2 to case 1. Now it will be easier to apply the step 2. So the step 2 will be nothing but this same solution that we had. That is left rotation of the BST with respect to the unbalanced node. Okay. So that means next time if you do the left rotation with respect to this, because this was the unbalanced node, we will find what? 2 will come here again, and 1 will come in this side, and then 3. So it's 0, it's 0, and it's 0. Balance factor is 0. And you see, again you can say that the in-order traversal remains same. That means there is no change with respect to the exact order of the tree, but we have solved the problem of balancing. Now the other two cases are actually the mirror image of case 1 and case 2, because case 3 will be what? Will be something like, just we have discussed about right subtree. Now we will discuss about left subtree. That we will consider that left subtree left heavy. Left subtree left heavy. What is the situation? It's something like, suppose now data set comes as 3, 2, 1. So what will happen here? That means it will be something like 3, then left 2, and then left 1. Right? 3, 2, 1. Now you see, obviously the balance factor for this node is equal to 0 because this is leaf node. But balance factor of this one is actually 1 minus 0, that is plus 1. And balance factor of this node 3 is in this side 2, 1, 2, and this side 0, that means 2 minus 0, that is equal to plus 2. That means this node is unbalanced. Now in this side you see which part is unbalanced? The left subtree is unbalanced. The node is actually unbalanced because of the left sub, right? And what I mean, which side of the left subtree is heavy? You see, the left side of the left subtree is heavy. Left side of the, left child is heavy. Left child is nothing but the root of the left subtree. So you can say the left subtree is left heavy, right? So if the situation is something like this, you see, if you check the previous case, when it was just a mirror image, we have done the left rotation. So just I hope you can easily guess that what can be a solution for this situation. That is, the solution is that right rotation. Now right rotation with respect to the unbalanced node. So that means we will have a right rotation in this, right? So if we have assuming that if we have some pulley or something is here with respect to which this side will be rotated, what will happen? This 3 will come downward and 2 will go upward, and so that means this situation will become something like 2 will come upward, and similar way 3 will come in this side, and we will have 1 in this side. 0, 0 and all 0. The same situation we can find. And the last one that is left, you can say case 4, that is, you can say that left subtree right heavy. So left subtree right heavy means the situation is again you can assume it is something like mirror image of this situation, right? So that means here the data can be something like 3, 1 and then 2. Suppose the data set given something like this and you want to create a binary search tree, what will happen? A tree will be created in a form something like 3 in this side, then here it is 1 and then here it is 2. So basically the balance factor of this node is 0 surely, because and balance factor of this node is 0 minus 1, that is minus 1, and balance factor of this side is 1 minus 2 minus 0, that is plus 2. Balance factor has not changed from this side because ultimately left side heavy, right side heavy, doesn't matter, ultimately the left subtree is heavy, so it remains same. And I hope you can realize, you can easily guess the solution for this case also. That is, here also the solution contain several steps. What is step 1? Step 1 is left rotation with respect to the left child of the unbalanced node. Just we have seen that right rotation with respect to the right child of the unbalanced node, similar mirror image left rotation with respect to left child of the unbalanced node. And to do this, that means we are doing something like this, right? So ultimately what we have done, we have converted this problem to a problem of something like this, that is 0, this is 1 minus 0, that is plus 1, and this is 2 minus 0, that is plus 2. So we have basically by the step 1 converted the problem from case 4 to case 3. Just in previous situation we converted from case 2 to case 1, that's all. And then we can apply step 2, that is right rotation of the BST with respect to the unbalanced node. So that means we will have right rotation in this side. So what we will get? We will get 2 will come, I mean obviously 2 will go upward, 3 will go downward in the right side of 2, and 1 will remain in this place with respect to 2. So it's 0, it's 0, and it's 0. So we have got same situation. Now it is balanced. So these are the 4 situations that is possible. Either of these 4 situations will arise. So when when you are going to create a balanced binary search tree, you can face one of this situation, and then you have to identify, and according to you have to act. And as I told you, there can be a situation something like more than one node is unbalanced at the same point of time, and they are in different levels. It may happen. In that situation, we always correct the node which is in the higher level. In most of the cases, we find that correcting the node balance factor in the higher level automatically correct the balance factor in the lower level. We have, in most of the cases, we find that. But still, if correcting the balance factor of a node in the higher level doesn't correct properly the balance factor of the of a node in the lower level, then just you have to apply the solution for the lower level ladder. That's the only thing. Okay, but don't ever try to keep the balancing properly in the lower level first and then higher level. Don't do this. That's a wrong choice. That's a wrong approach. Always remember 2 points. First point is this one, is going to be very vital. Calculation of the proper balance factor is very important. So this is important. If you wrongly calculate the balance factor, everything will fail. Second point is that you have to remember these 4 points. And third point is that if a BST has more than one node unbalanced in different levels, then we correct the balance factor of the higher level node first, and then the lower level nodes. So you have to remember this point. This is also going to be very vital. If you just have a mistake for balancing in this situation, your entire balancing will fail. So these are the points we have to remember when we will try to balance in the a binary search tree. So now we can see an example by which we can see that how we can balance a binary search tree like an AVL tree. Okay.